Alright, in this video we'll just do an overview of the Altia toolchain in general, from our plugin to Adobe Photoshop at the top end of the graphics chain, through into Altia Design, our integration and GUI development tool, all the way to Altia Deep Screen, our code generation tool. We'll actually put some GUIs on hardware today. If you hear me say GUI, that's graphical user interface, or if you hear me say HMI, that's human machine interface. Pretty much interchangeable terms. So what this video will cover is what is Altia, what does it do. We'll also do just sort of a high-level overview of the product toolchain and do some demonstrations of certain pieces of the toolchain as I discussed. So what you want to think though, just in general, is when you hear Altia or see Altia, think graphics, and that's because we focus just on creating GUIs. So we don't manufacture chipsets or anything like that, but we optimize GUIs for deployment onto those pieces of hardware. So just to give you an idea where Altia comes into play in terms of production hardware in the environment today, we have various deployments. Here's one on a Nordic track, and it's got a pretty high-end touchscreen, large touchscreen with Google Maps integration and lots of cool interactivity on the unit itself. And then moving on, we actually have some pretty low-end devices as well. These have high power restrictions. That is, they have a power requirement to be very low power consuming because the battery needs to last at least a week for these devices, as well as power the pump itself. This is a wearable insulin pump for a medical device technology company. All right, and then finally, we have high-end deployments in automobile sector. This is just one example. As it pans up to the dashboard there, that is all powered by Altia. There's not a single plastic gauge there. It's all just Altia graphics doing the entire virtual instrument cluster. All right, so as we move on here, I'll be talking about how this works for any type of interface, and here's just one more example of a building automation, built-in appliance, security system, utility sort of touchscreen interface. And then we'll kind of, as we go through here, sort of reiterate Altia's mission. And what is that mission? Well, Altia tries to get the best graphical user interface from the artist's imagination to the lowest cost hardware in the shortest amount of time. And we're going to be showing you how to do that in the next few moments here. Alright, so how this all works is basically every GUI is developed in these three steps. And that starts in Adobe Photoshop. We found that many of our customers prefer to generate their graphical concepts for their GUIs using Adobe Photoshop. So what we did is we wrote a native plugin to Photoshop called Altia Photo Proto, and that analyzes the graphics artwork in your Photoshop file and allows you to create interactivity and prototypes straight in Photoshop using the Photo Proto plugin. The Flow Proto plugin is the same thing but for Microsoft Visio, so you can draw flowcharts and get sort of a logic core model from the state chart you draw in Visio. We do have connections to larger logic modeling tools like Simulink and StateMate and StateFlow, but we'll talk about those later with the API. Once you get your graphics fleshed out in step 1, you go to step 2 and you integrate that as a GUI in Altia Design. And this is where you add additional animations, additional interactivity, user input events, further for motion tracking or gestures, things like that. You might use the API to connect to external code. And once your GUI is completely finalized in Altia Design, you then generate code using Altia Deep Screen. And that's the part where you leave Altia Design and you actually begin to generate binary executables for the hardware target of your choice. All right. So to illustrate that, in a few short moments here, I'm actually going to start from Photoshop, Adobe Photoshop, and end up in Altia Deep Screen and land on Freescale IMX6 board that I have here on my desk. So I'm going to do that 1, 2, 3 process for you real quickly here. And of course we do start in Photoshop. And this is just native Adobe Photoshop, but we taught Photoshop's layer comps a new trick. Instead of just being various layouts for like a magazine or cover or something, we actually used the layer comps feature to define separate screens of your GUI. And then within those layer comps, we have objects that consist of layers that have keywords in them, like button or deck. All right, and if you've watched some of the videos in the knowledge base on support.altia.com, you can see what a deck is and what an image object is. But basically, PhotoProto is able to analyze a Photoshop file, look for those keywords, and generate workable, deployable graphics. And let me show you what I mean by running the script. If I run Altia PhotoProto with the default options are fine, click run. If you're a Photoshop user, you may realize the power of what's going on right here. Per layer, it's creating a perfectly trimmed PNG file, naming it based upon what you called it in the layer. It's going ahead and looking for those keywords like button and deck, and if it finds those keywords, it creates an actual clickable button or a deck. And also for the buttons that you tell to switch screens, it's creating that behavior as well. So in about the time it took me to explain that, you have now a multi-screen GUI with clickable buttons that you can preview in this nice preview window that pops up when the script is done running. So instead of manually exporting all those images one by one, you know, copy, file new, paste, save as, and then give it a file name, it did all that for you. It's now generating a nice little preview window for you, and you can look and see and actually click through and see that your GUI is behaving exactly as you designed it in Photoshop. So Altia PhotoProto adds a lot of power to Adobe Photoshop because it is a direct plugin giving you real working graphics that you can pass down the line. What do I mean by pass down the line? Well, now we switch to Altia Design, right? And Altia Design is our main integration tool, and it's where you add additional features or external code. But what I'm going to do real quickly is just import the output of Altia PhotoProto, so we can test this in Altia Design and confirm that, yep, everything's here. But unlike with Photoshop, you know, using Photoshop and Altia PhotoProto, you just got the preview window. Well, here you've got real working objects, and you can modify your model and add to it or change things if you want. For this quick 1, 2, 3 demo, though, I'm just going to skip now step 2. I'm going to consider that complete, the Altia Design portion, and jump straight to step 3. So step 1 was Photoshop and PhotoProto. Step 2 is Altia Design. This is step 3, Altia Deep Screen. I click Generate Source Code, and up pops a window. And it's set up, but I just want to quickly discuss. This is your hardware targets that you have available as installed on your system. Major enables like anti-alias fonts, dynamic memory, do you have a file system for image objects, that sort of thing is checkboxes here. Make file and a compile flags file, what we call the bat and gen file per target. That's all set up, so I'm just going to click generate. Now, when you were in Adobe Photoshop watching that progress bar, as a graphics designer, you might have gone, boy, that's going to save me a lot of time, you know, manually saving all those images. Well, imagine how much time you're saving right here as a programmer, right? Instead of spending the next, you know, day, week, month, whatever, hand coding all this C code to create the user input events, the screen changing, even the graphics blending of each of those alpha channeled images. Now that's all done for you, and it's optimized C code for the target that you choose. I chose an IMX6 in this case, and so any sort of rotation or scaling, those are hardware accelerated graphics operations that will be done optimized for the IMX6, and it's not a runtime engine that you need just to draw a rectangle. Nope, it's only the C code that was generated for what you created. So that's done. Let's go over here and actually compile the code. I'm here in VMware image because the IMX6 I have on my desk has a Linux environment, so I'm compiling the code in a VMware image of an Ubuntu system so that I can compile that code. It pauses briefly on this Altia image databank file because it's baking in all the image data into the single binary executable. That's just a code generation option I chose. I could have left all the images separate from the binary executable and reference those on a file system should I decide to do that. So again, code generation leaves you with a lot of options there as well. It's done, so let's just go ahead and take a quick peek at what we created here. Alright, what we've done is initially we generated code, and that was all the C and H files you get from generating code. Then when you compile that code, you end up with a single binary executable. It's 2.6 megs, named the same as your DSN file. Okay, I'm going to now use NFS to copy that file from my system here. Let me clear it so that you can see what's going on. I'm just going to copy the file from my local system via NFS to the root directory of the Freescale IMX6 board on my desk here, and I'm connected to the board directly with TerraTerm here. So if I just modify this path here with this copy. I just need to match this directory, so it's red phpr and then red phpr assets, and then we called the file red phprds, and I'm just going to put that at the root level of the IMX6. So while that's going, I just want to once again reiterate the process. We started in Photoshop, drew up the graphics and the layers in Photoshop for our interface, used Altia Photo Proto to generate those working clickable objects. Then we came into Altia Design, and if we wanted, we could add additional animation or add other objects and user input events or external code. But when we were done, we generated code, got the CNH files, went ahead and compiled it, and then copied it to the IMX6. So now if I just do a quick ls, you can see that it's sitting there, red phprds. Let's go ahead and run that right now and hit enter. And at this point, I want to bring up a webcam. This is showing the IMX6 on my desk, and it's running what we've just generated from Photoshop, put into Altia Design, generated code using deep screen, and now have deployed on the IMX6. And you can see now that everything that I was able to do in Photoshop, I'm able to do directly on hardware. Because it's so quick to do this, you can make hardware level iterations to your GUI and test them on hardware. So you don't have to make decisions about what you think might run on hardware with your GUI, what you're developing. No, you can just make changes and go test it on hardware, because the process to get down to hardware is that quick and that easy. So using the same process, you can repeat this for any Altia Design target we support. This slide just has a few of them up here, okay? And that goes from low-end to high-end targets. Some of these don't even have an OS, let alone an RTOS, real-time operating systems. We have Altia code generation targets that target the chipset, and we provide the GL, that is the graphics library. So we handle all the drawing calls and everything like that. But on targets that do have accelerated graphics, we make sure that our deep screen targets are optimized to take advantage of any of that hardware acceleration. All right, so another example, and here's just a collection here. One same Altia Design file can be generated for multiple devices to see which runs the best performance-wise, but maybe also meets somewhere in the middle from a cost standpoint. So you can generate code from the same model onto different pieces of hardware, what we like to call trying it on. You can try on that same interface into different pieces of hardware and see which one runs the best but still meets your cost requirements. All right. So I did the sort of A to B process real quickly. Now I'm going to show you some features, so specific feature demonstrations as we move along. But before that, I want to just give an overview so that you have a little framework of what I'll be talking about next. In the bottom row, there is 3 key objects, and these key objects form the basis of every GUI in Altia Design. You basically will not be building GUIs without using these 3 objects. So the deck object is like a deck of cards or flashcards. You show one thing, then show another, then show a third. All right, and this is great for things like switching from the home screen to the settings screen, because you show one screen, then you show the next screen. But it can also be used to flip cards between just 2 cards for something as simple as a button. You have an upstate image, and you flip a card to the downstate image, and back and forth for the button as it gets clicked. And finally, we'll talk about keyframe animation coming up here, but sometimes Walt Disney had it right. The best way to do an animation is to show a sequence of images like a flipbook style, and this is good when you're exporting artwork image sequences from like 3D Studio Max or Maya or Lightwave 3D or Adobe After Effects, something that has real high-end graphics power that you just want to show in your GUI but don't quite have the performance to render that type of graphics in real time. A deck can play that back as a flipbook style animation. Alright, so the image object is the next key object, and that is just a container that references a graphics file on your disk, like a PNG image. And it's great because anytime those files change on disk, your GUI's updated, and you can tell those image objects to instantly reference other images. But when you generate code, you can tell those images to maintain their external link to those files if you have a file system on your hardware, or bake all those images in, as I did in that previous demonstration from Photoshop to hardware. So the image object is basically what you use to get artwork into your model. And the text I/O stands for input output, is the object that you use to put dynamic content on your screen. And this could be numeric readouts for speedometers or RPM or temperature sensors, to just strings that need to sit there in your GUI to relay information. That could be a dynamic message, or it could be just a string that does not change through the course of the model unless you change languages. If you have localization built into your GUI, you'll use a text IO to change languages. So those are the three key objects. Of course, there's additional objects, but those are the three that you will always end up using. So you might be asking, okay, great, I understand the three key objects. How do you make an entire GUI out of that? Well, you take those three objects and you start bolstering them with the top row content. Across the top, we have animation, stimulus, control, and API. So animation is the motion. What do objects do? Do they fly around? Do they bounce? Do they fade in and out? Do they wipe left to right? Do they rotate? Do they distort like a barn door? Anything that you can do to transform an object, you can animate across time, and that's the motion. That's what makes the rich look and feel of your GUI. It makes it look high-end and polished, is all the animation you put into it. Stimulus is the user interaction. If it just looks great, but the user can't play with it or do anything with it, you've built a movie, not an interface. Right? So the stimulus is that user input. How does the user interact with the GUI? And finally, you have control, and this is the logic that powers the decisions in your GUI. So this can be internal with Altia control code, and that's a forgiving, fill-in-the-blank programming language with a lot of syntax help for you. But if you don't want to do that, if you don't want to program internally, you could also just power your GUI by external logic using the API. And this can take the form of hand-coded C, or if you have a logic modeling tool such as Simulink or Stateflow or Rhapsody or any one of those types of tools, you can use API code to power those logic models to actually control what happens in your Altia GUIs. All right. So let's move on now and talk about the specific features that I wanted to highlight today. And that's animation is so big a part of GUIs these days that I'll start with that. So in Altia, you have keyframe animation, or animation by example. And this is really done by just giving it a start state and an end state. And you click define to set that as a keyframe, and it's going to go ahead and figure out everything in between. So if you have a start state at 0 and an end state at 100, by state 20, it's going to say, okay, well, I know I started over here and I end over there. I'll interpolate, that's the term, I'll figure out what's in between 0 and 100 in order to arrive at 20 or 30 or any other state in between. All right. So I'm going to show you an example of that now, but I want to keep some things in mind as we go through this. I'm not going to write any code. Anything I do to this object, I can affect it internally, manually, or externally via external code, and I can even add input events to control these animations later. All right, so let's just jump over and show you a quick example of that. I don't need this file anymore, so I'm just going to go ahead and open the file that I do want to use. And we've got a nice picture of a instrument cluster here, but we don't have a needle. So let's fix that. We start by going to the insert ribbon and just choosing a model library that we built. Anytime you save a DSN file, that's the Altia design file format, you can then turn it into a model library to drag parts of it in for use later. So I've done that with this needle. I just dragged it in, position it. It doesn't have to be perfect for this quick video here, but I do want it to look like it's sitting on the center of that hub. And that looks pretty good there. So what I'm going to do is actually create an animation on this object. And it's very simple to do. I just make sure I'm in the animation pane. And I type in an animation. For example, speed. This could be anything you want, but I want to call my animation speed. So I typed in speed. Now I could do tab space to hit define, but I don't want to do that quite yet because I want to rotate it first. So I just click the rotate tool, click and drag on the needle, and now that it's in the right place, click define. That's its start state. Then I click and drag on the needle again and click define after changing this value. Now I'm going to choose, I could define state 10 and then it would go chunk, 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 but that would be choppy. So I want 2 states of animation per mile an hour, which with 140 miles per hour equals 280 states. And then I'll just click define. So its end state is 280, its start state is 0, and I can click the animation here in the animation pane and actually preview that animation using this slider or down here with the roller mouse. So there's a lot of different ways to see your animation played back here with Altia Design 11. But my favorite is when you select the animation here and it's blue, you can use this nice slider. Alright. Okay, so jumping back then, we have shown you how to quickly create animation. I did this without code, and now that needle is rotating. If you generate code for the IMX6, it knows how to rotate alpha channeled images as a hardware acceleration. So that is very, very quick, easy to do, no code, right? And you can power it internally with your hand like I did, or external code or internal control code, so you can affect those animations very, very easily. So now we're going to move on to that other key object I mentioned, DEX. DEX can do things such as provide two images, a way to quickly show one card and another card in the sake of a button, or in the case of a button. Or they can switch entire screens from like this weather screen to the engine screen, tire pressure, simply by changing the center content there as a card of a deck. So one card would contain the center content for the weather screen, the other card center content for the engine screen, and so on. Not pictured on this slide here, but the third very good use of an animation, of a deck, is for those flipbook style animations. And Walt Disney had it correct at those times. You know, the best way to do certain styles when you want Hollywood volumetric effects with smoke and fire and water and dynamic fluid calculation, sometimes that's better to render it out an image sequence in a powerful graphics tool and just play it back in your GUI as an image sequence. A deck can do that as well. Alright, so let's jump over and talk about DEX in Altia Design. I want to create a button out of these two images, and I want this image to show and hide, you know, as you click it. Well, the very first thing I want to do, just because I don't want the button jumping around when I click it, is make sure that these two objects share the same space. So I'm just going to align their bottom edges there. Alright, so they're sitting there, and I can now insert a deck, insert deck, just drag it in and place it somewhere nearby. Now deck comes, you can see you've got a deck and then a child of a card, right? And the children of the card are just these sample objects. And I really don't need any of those sample objects, so I'll just delete those. Alright. So I've got an empty deck here now, and that's good because that's what I want. What I'm going to do is select this upstate image object and drag it to the title of the deck. And that shoves that image object into card 0. I then select my downstate image object, do the same thing, drag it onto the title of the deck, and it shoves it on card 1. So now for my deck, I've got a nice little card animation that I can play back here. Oh, I've got my animation speed in this value place right here, animation speed state. I'm going to first select 36 cards, so it's down here, and then I can change the value. And you can see that it's 0, 1, 0, 1. That's the card animation for the deck. Okay, well, 36 card is not necessarily human readable. I'm going to make it match this naming convention I've chosen for my audio button here. So I'll just make it audio BTN press. And that is the same animation. It's the deck card animation, but it's just named better to control from external C code, or if you have it selected and are looking at it, you can get an idea of what it is. I could have named that audio button card too if I wanted, but audio button press is good for now. So we've created a deck with two cards, card 0 and card 1, and if I set the card animation to a value, it simply shows the contents of one card and the next. And card 0 is that upstate image, and card 1 is the downstate image, the pink one. Okay. Well, of course, inside of those are image objects. So you're kind of catching the trend. It's all image objects and decks, right? That needle we created earlier is also an image object. All right, so let's go back now. Why do you want to use decks? Why are they so beneficial? Well, just that one simple object allows you to switch screens of your GUI, create buttons, you know, like we just showed, or even import image sequences from external tools and play those back in flipbook style animations. So a key object to creating GUIs in Altia Design. We're moving on now to stimulus. We created essentially the animation of a button. It's capable of looking like it's a button, but it's not capable of being pressed yet. That's where Altia Stimulus comes into play. And it's quite quick and easy to implement as well, just with point and click, again, no coding. And so we're going to do that on the button we just created. So what we're going to do is we're going to create stimulus that affects this animation audio button press, so I don't have to use the arrows or my roller mouse to change that value back and forth. Right? So let's select the stimulus tab. And we've got that button object selected. That's good, because we don't want to define stimulus on this guy or this guy. We want to define it on the button. So we make sure we have it selected. and we do a left down event on the whole object. So basically anywhere within these control handles, it will pick up this event. And this if condition is optional, as it says in the tooltip, and it's basically saying do this only if. Well, I want the left down event to happen all the time, so I'm just going to leave that blank. Then I'm going to say execute. Execute what? Well, I can begin typing my audio btn, and it's going to autocomplete, so I can down tab and then just set that to 1. So if I go into run mode now and click left down on that button, it should turn pink and set that audio button pressed to 1, and sure enough it does. Now, run mode and edit mode is worth pausing briefly on. If I'm in edit mode, I can actually select objects, move them around, that sort of thing, you know, develop my GUI. If I'm in run mode, you actually switch to this finger icon, and anything you click doesn't get selected, it actually gets pressed if it has stimulus on it. So it's putting your interface, even though you're in an active edit session of Altia Design, it puts your interface into to run as if it was deployed already on target. Okay, so edit mode and run mode is certainly worth mentioning. Now, you might have noticed that it's pink and it's not coming up. All right, we've got a stuck down button. Well, that's very fixable. We just create a new piece of stimulus, which is a left up event. And on this case, I'm actually going to do a large rectangular region, something like 10,000 by 10,000. And the reason I do this is just because human beings tend to have a sloppy up. That is, they don't release their finger exactly where they pressed it, especially on a touch screen. So you give them the ability to remove their finger anyway and still have the button come up. But because you're detecting such a large region, you don't want all your buttons on the screen to detect events when you release a mouse button. So you if check it, say if audio button presses 1, then set it to 0. Otherwise you don't want to do it. So you check first and then set it back to 0. So now we have a left down and a left up event. So let's click run mode and click the button, and sure enough it works even if we release away from the button, so it does not get stuck down. Alright, so that's basically stimulus. You know, you've got various input event types with that drop down, so you specify what and where and then do what. So what to execute when that happens. And that makes it so easy to add user input to your GUIs on hot areas or special objects, and this can do everything from left down, left up, which by the way translates to finger down, finger up on a touch screen with our Altia deep screen targets. You can do motion detection to set up motion grids for things like gestures. You can do enter leave events. So it's really, stimulus is where it's at to add that user interactivity, the user input events to your GUI. Alright, dynamic images have been mentioned. I mentioned that the image objects inside the deck for the button, there were image objects for the needle that we rotated. But now we're going to talk about one key benefit of the image object, in that it is actually truly dynamic, even at runtime. And so in your pocket or on your PC, when you click the next track button on your media player, most often you'll see that album art update, right? And that's in GUIs from devices to full-on PC applications. And that process is done by having a container object that's capable of referencing and pulling in a new image. Okay, so that's what we do with the image object. And without further ado, let me jump over to Altia Design and just show you how that's done. If you select an Altia image object, it's got properties, and properties are just easy access panels to the built-in animations on any object. But one of the properties is image name. So if I click this and I change this to stained.png, it suddenly references the stained album art rather than the STP album art. What my hand did is just sent it a new double-quoted string, and this is the same thing the API would do. Okay, so I did this manually and virtualized an API command to update album art when the system gets an extract event. Alright, so to give you an idea of what's actually happening behind the screens, though, behind the scenes, I should say, is if I explore the working directory, you can see that it's referencing a subfolder called the MP3 images, which we do have right here, one level down, and stain.png or stp.png. So it's simply a relative path to the file name. Alright, so that's updating one image for album art, but you can actually go through and update all the images in your GUI to do what we call skinning your GUI or retheming your GUI. And this allows you to, using those image objects and just telling all the image objects to pull in new artwork, you can instantly change your GUI from like a day mode or a night mode, or rebrand it entirely if you have multiple brands in your company. or your organization, and you want to have the same GUI and the same logic, same animation, same behavior. You just want it to look different per brand or per customer, or whatever the needs might be. Skinning and theming interfaces with the image objects is also possible using the same image object dynamic update method. And once again, the key is this can happen at runtime. So not just here in Altia Design, I'm making changes to my GUI. No, I can do this at runtime. Alright, so let's move on. I keep talking about the API, the external code. Well, this is the part that allows you to actually control your GUI from external code with C code. And there's a lot of mind share in C, and you can check in your source code to source control systems. So there's a lot of reason to want to power your GUIs with external logic. Well, our API allows this quite readily and quite easily. We have a function called AT-add callback, which is basically registers event listeners, and there's a few ways to do this. I'm just focusing on this method here. And when this event comes in from the GUI, it's going to call a callback function called press callback, and that function just says, okay, if value is 1, if audio button press is 1, do something. And what it's doing, it's changing AT-send event the value of speed, 0 to 255 in this case, and then if it's not 1, if the value is not 1, audio button press is equal to 0, it's going to reverse that. It's going to set the value of speed from 255 to 0, essentially sweeping the needle up and down based upon the value of audio button press. Okay, so let's quickly jump over to Visual Studio now and show that code for real on screen. And we've got the 280 value here because that's what I define my animation as, not 255 as shown in the slide. That's fine. Audio button press is our event name that we're listening for, and we do that by registering a callback. The Visual Studio project has been set up with a couple project settings to include dependencies, but that's all very straightforward. We included altia.h to use this code, of course, but essentially we had what we have on the slide. We listen for audio button press. If it's 1, we change the value of speed going up, and if it's 0, we change the value of speed coming down, sweeping the needle essentially from min to max and then from max to min. So let's go ahead and show that in Altia Design. Remember, earlier on we defined an animation on this needle called speed, right? And we made it move back and forth based on that animation. So from 0 to 280, the needle can rotate. Okay. We also defined we renamed the deck card animation to be audio button press and defined stimulus on that so that in run mode we could click that button. Notice nothing happens between these two objects right now. There's nothing telling them to interact. Let's go over to the file ribbon here and click client and start client. By the way, just to make sure, I think it's already built. If I hit F7, it should say up to date. Yep, it's up to date, so I'm just going to go where it is and choose it. So I've double clicked it. Now, if you're wondering, that's Win32 code. Yes, correct. For a production deployment to hardware, you would link in all the Altia graphics code and your external logic into the final compiled project. What I'm showing you is the same principle of how to use the API, but actually how to leverage compiled code against an active Altia Design session. What I mean by that is when I connected that, it says, okay, I've got a client running on port 5100 now, and it's running that code. So if I'm in run mode now and I click audio button press, I change that value 1, 0. It's affecting the value of speed exactly as the code told it to. So this is really neat because I can continue editing my GUI and maybe put the needle over here, make changes, whatever. But the C code is ready and willing to always affect my objects in the same way. So this is extremely powerful. Not only am I in an active design session running in real time compiled code against my model, but I'm able to verify that my logic is doing the correct thing and my graphics are responding with the right animations that I've built. So very, very powerful real-time external code connection using the API. Okay, we mentioned decks enough, changing from screen to screens. I'm going to show you that deck changing from screen to screens in this model coming up, but I'm also going to illustrate how you can just make quick animations on a deck, a parent group, parent of the deck, you know, and so it will affect anything inside the deck to create screen transitions. And if you've seen an iPhone or an Android device, it's it's the polish, it's that zing that adds that real nice finesse when a screen, instead of snap from one screen to the next, instead transitioning, sliding, wiping, fading. That's the thing that adds that final layer of polish and completion to your GUI. So let me quickly show you how that's built in and easy to do with Altia Design. So I've made a mess of this one. I'll just go ahead and open this file here, and I don't want to save my previous work, and that's fine. So this has lots of working parts, lots of cool animations, right? Alright, but if you can see, it's quick though, but instead of just snap from screen to screen, there's a slight fade in animation. So that's what I'm going to be focusing on right now. If I focus in and select this, you can see it's a deck and it's got a 29 card. And if I change the value of that card, it just changes screens. Alright, if I right click and do collapse all here, and show you that deck, this deck right here, Altia screen deck, has 5 cards. And those 5 cards just happen to match the values of the screens. Okay? Now that's the transition you would get normally if you did not add some sort of pizzazz screen transitions. Just snap. Well, also on this deck there's a little animation called highlight opacity, and that makes it fade in. And that's how you see that nice fade in when you switch from screen to screen. Well, let me now select this this deck object, and setting the highlight opacity animation at 0, I'm just going to now drag the object down and click define. All I've done is I've said, hey, for that animation, redefine state 0 to move down here. So now instead of just fading in, it moves up and also fades in. Okay, so if I focus out now and go to run mode, you can see that now not only do we have a fade in, we have a move up animation. Alright, so that allows you to see how quickly and easy that polish, that final pizzazz or sheen on your GUIs can be implemented using screen transitions. And the other intangible about this is when I redefine that animation and played it back by clicking around the GUI in run mode, not only did I say, oh yeah, that's moving up and fading in, so graphically my GUI is operating correctly, but I was also once again able to verify logic. Because I clicked this button and saw this screen, I can say my logic is working correctly as well. And that's all in real time. Alright, so these processes and these objects that we've been talking about before, when you get your GUI done and finished and you're ready to deploy on hardware, you leave Altia Deep Screen, you leave Altia Design and you enter the world of Altia Deep Screen. And that's done from the code generation ribbon. So let's go generate some source code and put this on an IMX6. Alright, and so what we want to do is go ahead and open, I'm just going to open that file on itself again, make sure it's a perfect state for code gen, and click generate source code. Now by clicking this button, we've left Altia Design and entered into Altia Deep Screen. And again, just sort of a review, this drop down list is the hardware targets you have selected, major enables to turn on or off major features, such as dynamic memory, anti-alias fonts, do you have a file system, so on and so forth. And you choose the bat and gen file, and that's the make file and compile flags and additional targets. So when you have this set up, we're set up for the IMX6, click generate. Again, there's a lot of interactivity in this model. There's a lot of animation, there's screen changes, there's screen transitions. Each one of those image objects is a PNG with an alpha channel. All that blending is being taken care of. None of that is stuff you now have to hand code. It's being generated for you as we speak. Alright, and it's very quick to go get a cup of coffee. Well, I don't have time for a cup of coffee, it's already done. But it's much quicker than spending the next day, week, or month, right, doing this by hand, because it's already done in less time it took me to say all that. Alright, so let me jump back over to the Ubuntu image here and run the make file for this GUI. And it pauses here on image data bank, just like it did before for just a bit. Alright, so it looks like it's finishing that up, and it's going to link the other files in and finish the build or the compile process. And we've got it done there as well. As before, I want to go to the folder where that got built and just show you sort by date modified. There's our demo 7 there, 1222, 1222. If I turn on the size column, you can see it's 4.3. This is bigger than our last interface because it has more objects, more animations, more cool effects on each and every screen. Once again, I decided to bake the image content into the binary executable, so we've got it sitting here. Alright, so let's go ahead and just like we did before, we'll jump back to TerraTerm now, and I'll kill that process and check top, make sure we have nothing we don't want running. That's good. And now let me just go ahead and do the very same thing as we did before. I'm going to copy that resulting binary executable to the root folder of the IMX6 on my disk. Alright, so that's good. Just want to make sure I'm there. I'm in root. Alright, so I'm just going to run demo 7 now and hit enter. And once again, I'm going to bring up my webcam, and we have it sitting there. You can see the IMX6 and our new GUI. So let me poke through these screens on the touchscreen real quick and show you that everything we generated, you know, the rotating needles, animated weather icons, those are those image sequence deck-based animations I was talking about, whereas these rotating needles, those are the keyframe animations that we showed earlier on. So all these screens work. It's very responsive, right? Everything's looking good. Let's go back and make a quick change though to show that you really can make iterations all the way at the hardware level, so you can test new things directly on target rather than developing more to your GUI and then hoping and praying it works when you finally get it on the hardware the next time that is. So I'm going to make a quick change. The change I'll make is just making this pink needle a green needle. Alright, so let's go ahead and do that real quickly. Okay, so we're back in design, Altia design here. And you know, there's the GUI we deployed. I want to make a quick change, as I mentioned before. So what I'm going to do is actually just make this needle green, and I do that by simply focusing in on the needle. Okay, and it's an image object, no surprise there. And I just change Speedo Needle 2 to Speedo Needle 3, and it becomes green. And of course, you know, if we wanted to, we could also do other things. For example, we could do something else, that highlight opacity animation. Let's go ahead and when it's state 0, let's move it down and I don't know, maybe shrink it just a little bit too, so it sort of scales up and moves up at the same time. And that way, you know, when we're playing around on our hardware, we'll see both the new animation plus the green needle. Okay. Alright, so let's go ahead now and generate source code. This is the same process as before. I'm not going to talk about this because it's just review, so I'll hit generate. Alright, and that's done, so I click done. And then just like before, we're actually going to come over here and do the alt make bat. Remember that this is a hardware level iteration, so we're actually making changes to our GUI and able to test it on hardware in a matter of minutes. This is an extreme benefit when you want to make sure that something you developed in your GUI is still going to run okay on your hardware. Alright, so it's finishing up now, and at the end we'll see done as before, but so no change there. Just as before, we're going to copy that demo 7 from the NFS shared directory on my PC to the root folder of the device. Alright, so that worked, and we've got the copy complete. Let's go ahead and, just as before, we're going to run demo 7, but we are going to make sure that we see the changes that we just built, and the way to do that, of course, is bring up the webcam. So there's the IMX6 running the GUI, and I'll come over here and press on the buttons, and I think I'll just jump straight to that speed screen. There's our green needle, but notice we've got that nice move up transition on the screens as well. So we made 2 quick changes to our GUI, and they're already deployed and looking great. Alright, so that's really code generation in a nutshell, and how powerful that using the Altia toolchain can be when you generate code and are able to test your GUI on hardware in such a short amount of time. So I did all of this, as you've noticed, without hand coding a thing, right? I was just pointing and clicking and getting it all running on target. This works on the IMX6 right now, but for any upcoming targets or that aren't in existence yet or other targets we already have available, you can do the same process and put this GUI on those targets as well. So you can adapt to upcoming or existing technology to switch targets when you want or if need be. And of course, the big benefit is, no hand coding. I did this all just with code generation and just compiled what was built from Altia design. All right. So there's sort of a wrap up. You can create animations without coding, switch screens, create buttons or flipbook animations with text, add user input events with the stimulus, load those images at runtime with the image object, connect and power your GUIs with external code using the API. We made transitions and of course generating code using Altia Deep Screen. That's the Altia toolchain from top to bottom. If you have any additional questions or would like to see more videos that get into a little bit more detail per feature, make sure to visit support.altia.com.